Class?
No, madam.
No question. Okay, thank you. Now, let's continue with the two population statistical inverse for two population. Now, for today's class, we are going to finish this all four because we have another class that should cover the non-parametric statistic for one population and two population. So that would be the last part of our chapter. Okay, so if we refer to our schedule, the next assessment should be on the 22nd of June, right? So that will be somewhere next week. Okay, but due to some reason, some of the lecturer did not finish covering the chapter 3 by this week. So they are going to postpone the quiz 2 that will be accounted for 20% of your marks. Okay, so I'm going to finish this today, and the last part of chapter 3 will be covered in your class on Friday night. Okay, so what we are going to cover afterward will be finding the CI for two population means, finding the CI for two population proportion, finding the hypothesis testing, performing the hypothesis testing for two population means, and performing the hypothesis testing for two population proportion. Okay, so when we, if you notice, we continue saying about this difference between two, difference between two, difference between two, difference between two. What does this means? Okay, now last time we are talking about one population. Okay, population one. Okay, population one. Okay, last time we are talking about population 1. And then from population 1, we take our sample 1. Then from this sample 1, we measure our X bar, we measure our proportion, because we need to make some inference for our population mean and population proportion. Okay, population mean and population proportion. Now, since we are talking about two population now, we expand, we have another population, population 2, and then we have also sample 2. And then of course, when from this second sample, we can now have the second measurement that will be X bar 2 and X bar 1, P hat 1 and P hat 2. And this reflect your mu1 and P1 and mu2 and your P2. Now, since we need to look for the what we call the two population, the best way to relate these two population is by looking at the difference between the parameter. Okay, so that's why here, in order for us to make statistical inference using population means and population proportions, so we are going to make the difference. That will be mu1 minus mu2 and p1 minus p2. And this will be estimated using the sample evidence of your X bar 1 minus X bar 2 and p1 hat minus p hat 2. So these are the things that we are going to look in after in your further discussion. So everything will be in terms of x1 minus x2, x bar 1 minus x bar 2, p hat 1 minus p hat 2, to reflect your difference in population mean and proportion. Now, as usual, if you are doing the calculation for the population mean, even though you are talking about one population mean or two population means, again, you have to remember there will be condition for your population standard deviation, whether your sigma 1 and sigma 2 are unknown or not known or unknown. Okay, if it is known, then you are going to use this as your calculation of your CI. Otherwise, if your n is greater than 30, means that your n1 and n2 greater than 30, then you have two options. Either the variance, the standard deviation of the population is equal is not equal or equal. If the n is less than 30, you also have the condition of unequal sigma and equal sigma. Okay, so this one unequal, this one equal sigma. This one unequal, so I believe this one is equal actually. Okay, so there will be different way of how to use this particular your calculation of your sigma and S. Okay, so let us look at the first example. So if you turn to your page, example 3.9 is somewhere in your textbook on page 95. Okay, page 95. Now, two machines are used to fill plastic bottles with liquid laundry detergent. The standard deviation of fill volume are known to be sigma 1. So in this case, obviously, you are being given the sigma value. So we know that sigma is known. Known sigma. So your sigma 1 is equal to 0.005. Sigma 2 is equal to 0.025. Okay. Two random samples of bottle from machine 1. So you have two samples. N1 is equal to 14. N2 is equal to 12. And the selected sample mean X bar is equal to 30.5. X bar 2 is equal to 29.4. Okay, construct and interpret 90% CI. So alpha 0.10. Okay, 0.10. So now, since we are dealing with known sigma, regardless of what is your sample size, so we are using known sigma. So we are dealing with this particular condition. Okay, so then we know that our CI would be X bar 1 minus X bar 2 plus minus Z 0.10 divided by 2, 12 of, so if you look at that one, so it would be sigma 1 over N1 plus sigma 2 squared over N2. So put everything together, so you will have your X bar 1 would be 30.5 minus 29.4 plus minus Z alpha over 2, you will get 1.6449. And this one is no, yes, yes, I am. Yeah, yeah. Uh-huh. So me off from the hospital. Okay, let's continue. Okay, now we have this standard deviation is 0.05. This squared over your n is 14 plus 0.025 squared over 12. Okay, so you will get here okay, so you will get 1.1 here plus minus you will get for here is 1.6449 multiplied with 0.0073. So if you simplify this will be 1 plus 1.1 plus minus so you will get the directly the answer lah. Okay, because I didn't. Okay, so you will get between 1.09 until 1.1. Or you can write as 1.09. That will be the difference for your population mean. Mu1 minus mu2. That will be until 1.11. Okay, so in this case, how can you conclude? We are 90% confident, okay, confident that the mean difference in field volume is in the interval of 1.09 ml and 1.11 ml. Okay, so that would be your conclusion. Okay, so very quick on the one of the equation of your exercise. Okay, so let us look at exercise 3.6. That will be on page still 59, 90, sorry, 95. Okay, page 95. Now, you have 17 male and female. So let's say male, okay, you have 17. So let's say male S1 equal to 17. Okay, and then you have female N2 is equal to 20. Are randomly selected from the Faculty of Engineering, then you have your X bar 81 is equal to 82. Okay, X bar 2 is equal to 76. And your S1 is equal to 8 and S2 is equal to 6. Okay, assume both population are normally distributed and the population variances are equal. So this is your first assumption. Okay, that will be equal variances. Now, look at your condition. Look at your N. Okay, is your N greater than 30 class? Less than 30, right? So less than 30, then you have to look for the condition N1, N2 less than 30. So we are going to use our t-test. Okay, P alpha over 2. Now, what else? Okay, what else should you know? Okay, what else? You are using the assumption that sigma 1 and sigma 2 are equal. Okay, so let's continue with the what we call the calculation of your PI. So you have x bar 1 minus x bar 2 plus minus z or not z t alpha over 2. So that will be 0.05 divided by 2. And then for t equal variance, so equal variance, so you are going to use this part. Okay, and your, sorry, n less than 30 equal variance. So this will be the one that you are going to use. So you have P alpha over 2 B. So that will be the condition. P alpha over 2 B. And then you have the multiplication of your SP. Okay. Your SP square root of your 1 over n satu 1 over n second, okay, and 2. So let's find SP then. What is SP? SP is obtained by n1 minus 1 s1 squared plus n2 minus 1 s2 squared divided by n1 plus n2 minus 2. So put everything according to the value. So you have n1 minus 1 is 16. Multiply with s1 squared. So that will be 8 squared plus 19. Multiply with 6 squared divided by 17 plus 20 minus 2. So you will get here, if you put everything together, you will get 6.9857. Okay, done with SP. What about square root? Square root 1 over 17 plus 1 over 20. So you will get here is 0.3299. Okay, what about P alpha? P 0.025. Your V in this case, okay, so V in this case is your N1 plus N2 minus 2. So look at your condition just now. So your V would be N1 plus N2 minus 2. So in this case, your V is equal to T 0.025, 35. So let us check our what we call t-test table. Okay, so for t-test, okay, look for T. Okay, so for T, our V is 35. Okay, and then we are looking for 0.025, which is this value, 2.0301. Okay, 2.30. Okay, so you have 2.0301. So now put everything together. So x bar 1 minus x bar 2, we have 82 minus 76 plus minus P alpha over 2 is 2.0301. Okay, SP is 6.9857. And then the square root of this one is 0.3299. Okay, so then you can have your answer would be 6 here plus minus. If you calculate together, this you will get 4.6785. And then your CI would be 1.3215 until 10.6785. Okay, so you can also write as 1.32. Okay, mu1 minus mu2 less than 10.68. Okay, if you can see the answer is a bit different. Okay, so 1.38. So if you can calculate, recalculate again, you can check whether this one is correct or mine is correct. I have calculated several times, but I still get this one. Okay, so how do we conclude? So we can conclude that, okay, so we can conclude that we are 95% confident that the mean difference of scores between all male and female students is between 1.32 and 10.60. Okay, so that's how you make your conclusion or make your interpretation out of your CI. Okay, class, any questions so far? Class?
No, madam.
You have any questions? Okay, thank you. Then we continue with the CI of the two population proportion. Now, for two population proportion, it will be simple since we don't have to deal with the sigma known or unknown n less than 30, greater than 30. So everything is straightforward. So if you wish to find the what we call the confidence interval for two population proportion, so first you will find and you will need to find the difference between the proportion sample proportion, and then you have to plus minus the margin of error obtained by using this particular calculation. Okay, so you can also rewrite as this one or using this one. And then of course we are dealing with, since we are dealing with two population proportion, then you will need to find what will be your first population proportion, and that will be obtained by using the x1 divided by the n1. And for population proportion, 2 will be x2 divided by n2. Okay, so as simple as that. Let's look at the first example of 3.9. Okay, example 3.9, that will be on page 96. If I'm not mistaken, there is a typo since I'm using my first version. So this is 3.10. Okay, 3.10. Now, check out all the information before you start. Okay, two separate surveys were carried out to investigate whether or not the user of class highway were in favor of raising the speed limit on highway. Of 250 drivers interviewed, okay, so cars, you are referring to cars, you have N1 is equal to 250, and then 220, so that is referring to your X1 220. Okay, in favor of raising the speed limit. And then for the second group, that will be motorists. Okay, so N2 is 200. Okay, 200 motorists, and out of 200, those who favor is about 180. Okay, find 95% CI. Alpha 0.05. Okay, so in this case, it will be simple. So before we start, find all P1 hat. That will be 220 divided by 250, and then you will get 0.88. And then P2 hat is obtained by 180 divided by 200, and then you will get 0.9. Okay, 0.90. Okay, for the Z alpha, so since we are using Z alpha over 2, so alpha over 2, that will be Z 0.025, and then that will be 1.96. Okay, so now, so P1 hat minus P2 hat plus minus Z alpha over 2, square root of P1 hat, Q1 hat, okay, divided by N1 plus P2 hat, Q2 hat divided by N2. So this would be 0.88 minus 0.90 plus minus 1.96 multiply with, so you will get here, if I'm not mistaken, it will be okay, 0.0295. So you will get here is between negative 0.02 plus minus, okay, 0.0579. So your CI would be negative 0.078 until 0.3, 0.038. Okay, or you can write as negative 0.078, the difference between proportion 1 and proportion 2 until 0.038. So that would be the two answers. Okay, and how do we conclude? We are 95% confident. Okay, confident. 95% confident. Confident that the difference between the proportion of car drivers and motorists who are in favor of raising the speed limit, okay, lies between between negative 0.078 and 0.038. Okay, if you wish to use the percentage, that will be negative 7.8% until 3.8%. Okay, so that will be how you can make the conclusion for your CI of your two population proportion. Any question, class? Any question? Any question? No, huh? Hello? Okay. Okay. Then let's just continue. We have another 1 hour. So let's very quick do this particular example for exercise 3.7. So exercise 3.7, you can look at your textbook on page 96. Okay. So let's say we okay. So let's say we do this. Okay. In a test of the effect of dampness on electric connection, 100 electric connections were tested under damp. So you have first condition, damp condition, okay, and the other one is dry condition, okay. And under damp condition, you have N1 is equal to 100, okay, and under dry condition, you have 150, okay. 20 of the damp. So means that your x1 is equal to 20 fill. 20 fill. And only 10 dry ones fill. For dry, x2, 10. Okay. Alpha is 0.90% is 10. Okay. So find your P1 hat. So P1 hat is equal to 20 over 100. So you will get 0.2. P2 hat equal to 10 over 150. So you will get 0.067, right? Okay. What about your Z alpha? Z alpha 0.10 over 2. So you will get 0.05. So that will be 1.6449. Okay. Now, can someone please, can you check how many students have entered my online class? Yes, so then continue. P1 hat minus P2 hat plus minus Z alpha over 2. Then you have P1 hat, Q1 hat over N1 plus P2 hat, Q2 hat over N2. Okay. Then put everything together. How many? Plus 0.20 minus 0.067. Can you check how many join my class now?
70.
70, okay. So means that 9 of you are absent. Okay, I will check the attendance. I have given you the link, so please make sure everyone what we call record your attendance in the given link. So this one would be 0.2 multiplied with 0.8 divided by 100, plus 0.067, 0.933 divided by 150. So you will get 0.133 plus minus 1.6449 multiplied with 0.0449. So you will get 0.133 plus minus 0.0739. Then finally your CI would be 0.0591 until 0.2069. Or you can write as 0.0591 P1 minus P2 0.2069. Okay, So that would be your answer. The hypothesis, sorry, the CI for your two population proportion. Now, how do we interpret? Since you need to interpret, so we are 90% confident, okay, that the difference, okay, between the proportion of connection that fail when them as opposed to dry is between 5.9% and 20.7%. Okay, so that would be your answer for your CI. Any questions so far, class? So we finished with the discussion on the confidence interval for two population mean and two population proportion.